So calcium metal is it's a shiny metal. It's not what you think. Calcium goes inside of bones, but calcium by itself, it's a metal. Fluorine, sorry, is it's a gas. It's a poisonous gas. Like it violently reacts with metals, so not so good to breathe this in. And yet the two of these together form something entirely different from their two constituents. So you've got calcium and fluorine, two very different things. When they combine together, it becomes something new. So we actually have naming rules on how to name these things properly. So I'm just going to use the notes set up for this, but if I were to name, say, sodium chemically bonded with chlorine, ionically bonded with chlorine, the first thing you do is write the chemical name of the metal ion. So sodium is the first one. Na is sodium. Then you write the second name, the name of the second element, the nonmetal, so sodium chlorine. And then the third thing you do is change the ending of the nonmetal to an IDE ending. So this becomes sodium chloride. This is how you name chemicals. This is how you name ionically bonded chemicals. Now, what about going the other way? What if I asked you what the chemical formula was for sodium chloride? Well, so let's try magnesium chloride. So magnesium, you're going to write down the magnesium has a 2+ charge. So chloride has a 1- charge. They're not balanced though. Notice that chlorine is -1 and magnesium is +2. So in order to balance this, we're going to need to attach another negative ion. Specifically, we need to attach another chlorine. So we need to balance that by adding another chlorine atom. And then to write the formula, you just count up the number of ions required for each. So magnesium, there's only one. Oops. There we go. Magnesium, there's only one of them, so you don't need to write the one. Chloride, there was 2 of them, so we need to write 2 chlorine atoms. So magnesium chloride is MgCl2. Now, there's one other special rule that occasionally comes in. Some of these ions, you'll notice, have multiple charges. So like iron, for example, it can have a +3 charge or a +2 charge. So how do we combine that together with something like oxygen? So like that's what rust is, when iron chemically reacts with oxygen. So let's go over here. If I had iron, there's 2 options for it. If I had Fe2O3, like this, and I wasn't sure which one I was talking about, which ion I'm talking about. Is this Fe2+ or Fe3+? Because it does make a difference. So let's break this apart. We've got 2 Fe molecules, and we've got 3 oxygen molecules. We're not sure which one the Fe is. It could be +2, it could be +3. We do know that oxygen can only be +2. So oxygen, or -2. Oxygen can only be -2. Fe can either be 2+ or 3+. So let's go back. So the oxygen must be 2-. So now you just need to determine, is this, it can either be 2+ or 3+. The only one that makes sense is the 3+, in order to balance them. Like this. So you end up with 6 total negative and 6 total positive. So we call this iron 3, with the Roman numeral 3, oxide. We designate this Roman numeral to tell us what ion charge our metal has. We only use the Roman numeral. We only use the Roman numeral when we're specifically looking at one of these atoms with multiple charges. When there's several different charges to choose from, different options that it could be, like for example, copper could be a 1 plus or a 2 plus. When you're determining that, and you're looking at how it balances with, say, oxygen, because they're going to look different. Like copper, if I had copper 1 plus, it would look like this. So Cu 2O. If it was copper 2 plus, it would be CuO, because if this was Cu1 plus and this was Cu2 plus, again, it's different because it requires 2 1 pluses to bond with 1 negative, or with 2 negative. This is 2 plus, so you only need 1 copper atom to bond with the 2 negative. And these different circumstances arise in different situations. So again, we need different names for these two things. This would be copper Roman numeral 2, like this. So copper 2 oxide. And this one over here would be copper, oopsie, this is supposed to be copper 1 oxide. And this one is copper 2 oxide, like that. So again, very different, different chemical needs a different name. You only use the Roman numerals when you're working with these ones with multiple charges to choose from. If I was working with zinc and I know it's 2 plus, I don't need to, like zinc nitride, if I were to combine those two together, so zinc being Zn, I know it's a 2 plus charge, and nitrogen is a 3 minus charge. So I need to balance these. So Zn, right now I have 2 positive and 3 negative. I need to add more positivity in there to try and balance this. So we have 4 positive now, but only 3 negative, so I actually need more negative at this point. So I've got 4 plus and 6 negative, still not balanced. I need more positive again. Now it's balanced. Now I got 6 total positivity, 6 total negativity. This will be Zn 3N2. And the name for this is just going to be zinc nitride. So name the metal first, then name the nonmetal second, and change the ending to an IDE ending. You don't need the Roman numerals in the middle because there's only one possible charge that Zn could be. It's 2 plus. That's it. It's 2 plus. Not 2 plus or 1 plus. It's just 2 plus. So to recap, you need to be able to take a chemical formula and change it into the chemical name. You do so by following the set of naming rules. You take the metal ion and name it. You take the non-metal ion and name it. And then you change it to an IDE ending. That's how you take the formula and change it to the chemical name. Going the other way requires you to fiddle with the charges a little bit. So if I told you I have some magnesium fluoride, you need to be able to tell me how many of each of those ions are in there. So magnesium has a 2 plus charge, fluorine has a 1 minus charge, so you would need 2 fluorines to balance the 1 magnesium. So together it would be MgF2. So taking a chemical name and turning it into a chemical formula requires balancing the charges. So that's it for ionic bonding. Thanks for watching. Until next time.